My name is Kofi Amoako Ofori-Amanfo from Ghana, and I am studying at Seoul National University of Science and Technology. My major is within the field of electrical and information engineering, specifically wireless networking. My research project currently focuses on vehicle to everything communication. It's called V2X. It encompasses the interaction between vehicles and its environment. So you could think of vehicles communicating with vehicles and other roadside units, pedestrians, and other infrastructure. When we consider V2X communication, we are looking at, first and foremost, the aspects of safety. So one of the frontliners of the technology has to do with ensuring that there are minimalistic accidents. So there is an overarching goal that in roughly the next 5 to 10 years, the accident rates will be reduced to as low as 0.1%. So that is the idea for which V2X has actually taken space. And it has to do with preventing as many accidents as possible. So that's vehicle to vehicle communication. And particularly when we're looking at pedestrians, the goal is to ensure that collisions with pedestrians are minimized as well, and even taken towards zero. That's its use case scenario. And particularly in Korea, we realized that V2X communication has to do with ensuring that pedestrians are safe on the road, vehicles are not involved in accidents as well, and vehicles and their drivers, right, would actually have good information, particularly communicating with one another, roadside units, that's for traffic lights, right, to ensure that movement on the roads are seamless. So there are so many use cases with it. With V2X communication, that's vehicle to everything. It encompasses a few fields that I would break down. So the first portion is V2V, which has to do with vehicle to vehicle communication. And with that, there is the objective to ensure that accidents are minimized as low as possible. So that, if we can use a typical example, is as you are driving, your vehicle would be able to communicate with another vehicle in the case where the other vehicle is about to make a right turn into your lane. Your vehicle would actually be prompted that this vehicle is about to enter your lane. So that prevents a lot of these collisions we see. So another aspect is V2P, that has to do with vehicle to pedestrian. And that is pretty self-explanatory, where we see that the vehicle is able to communicate with the pedestrian's device, either their tablet, their mobile device, or any other smart device that they have. So the use case with that as well is to ensure that there are no collisions between the pedestrian and the vehicle. And for example, if you are over a crosswalk or a pedestrian walk, you can get an alert if you are quite busy by listening to maybe some music, or you are hooked onto your phone, you can get a prompt that there's a vehicle approaching you. So that's the V2P scenario. We also have the V2I, that is vehicle to infrastructure. So typically when we look at these infrastructure around the road, for example, toll booth points, traffic lights, and most of these smart walks, and even we have these roadside sensors. All these devices ensure that communication is ideal. So another scenario again with V2I is where we could have the vehicle communicating with the traffic lights. In a typical use case scenario, if you are approaching an intersection and there is an ambulance also coming. In this specific field, the ambulance is most likely heading towards an emergency. So V2I communication would ensure that right of way is given to the ambulance, and other vehicles are informed about that. And within Korea, we see it with its use cases because there are currently implementations for V2I communication, V2P, and V2V as well, with a company such as Hyundai. they've implemented most of these things within their vehicle. So its use cases for human interaction and everyday life is being seen here. There are many technologies that have to do with that. On vehicles right now, we have some motion detection sensors, right? And the next thing that can be tagged on is an overarching node that wirelessly connects all these sensors on the vehicles. So the vehicles are equipped with these sensors. To the question, the side link communication is made possible with wireless sensors between these vehicles that are able to transmit information across vehicles. So the vehicles share information from their sensors that are gathered are sent to the wireless node, and because wireless technology occurs within a specific locality, it has a range. With that, the vehicles can communicate, with one another or with each other, all of them. So that's for side link communication. But when it has to do with vehicle to network, wide range communication, that is mostly employed with the cellular, because that has to communicate with the base stations. The base stations are pretty much like the network masts. I think the most basic one, if you are in your car and you are backing up or trying to park, your car would give a signal when you are getting too close to a curb, right? So that is one of the most minimalistic implementations of vehicle to everything communication. The fact that your car is able to communicate information with you by picking it from the surroundings, that you're getting too close to the curb. Other implementations of V2X technology seen in quite some high companies, right, particularly in the United States, in Germany, they have these implementations where V2P communication has already been rolled out. So cars are able to receive alerts when a pedestrian is crossing them, and pedestrians are also able to interface with cars. Yeah, so these technologies are really existent in its pockets. But recently I saw a YouTube video where Korea has actually implemented vehicle platooning. What that means is these trucks mostly have a dedicated truck lane, right? So in an attempt to lower emissions and to ensure safety to the environment, these vehicles are lined up in a very ordered manner, and their speeds are very controlled in an automated way. So vehicle platooning has to do with the fact that there is a leading vehicle that ensures that all the vehicles behind it follow a very ordered manner. So if there is a speed limit that has to be kept to lower the emissions, because that is the core thing, there is a structured way that these vehicles follow. So with vehicle platooning, it's mostly dedicated for these big trucks, since they tend to emit more and take much of the space. So when these trucks are platooned, controlled by a lead vehicle and ordered in a good way, other lanes are very free for other cars to actually utilize. Another news item that I saw was the fact that they've rolled out 9 automated buses. So that is a very core concept of vehicle to everything communication, where autonomous driving is what leads the forefront. So particularly with safety, that comes as the prime goal, to reduce as many collisions as possible and to ensure that the driver and the pedestrian are safe. So that is one of the most important portions of vehicle to everything communication. Two is also, then again, with the vehicle platooning case, with that, it's to reduce emissions and to ensure that these vehicles travel at a controlled speed. And another aspect is to improve communication between these vehicles and to make the environment and the transportation system very safe and reliable. There are quite some drawbacks and very understandable ones, because with every new technology, the interface with humans has to be considered, and it has to be integrated in a way that is very comfortable for humans, because technology aims to improve our everyday lives. So those interacting with the technology must have a sense of calm when using it. For that, the main concern that has to do with V2X system has to do with the autonomous driving. There are main concerns where it will take a level of trust, particularly to ensure that one can give their entire faith to the vehicle to make sure it keeps them on the lane safely and does not lose its mind. That is one of the most pertinent issues that a lot of people have with it. Also, the technology of the wireless communication, it's one that has to be very flawless, close to flawless, to ensure that data transmission has as low latency being delay, as possible, because the most minute amount of latency can cause issues. So that is why most of these technologies come through, where we are seeing the rollout of even 6G. 6G aims to drastically improve data rates and efficiency to ensure that latency is minimized to the barest minimum. So that portion is also a challenge and an issue that is faced by the V2X field to ensure that communication is close to perfect, seamless. Another very huge drawback has to do with the semi-autonomous driving, where there is a typical use case of V2X communication where you could delegate access of your vehicle to a remote driver. So that in itself is also known as remote driving, where, for example, you feel a bit sleepy, so you want a remote driver to take control of your vehicle. That remote driver, if you're unaware of the state of the remote driver, or even if it is an AI robot or a human, that trust level can also be a case or an issue where you are uncertain whether you would safely arrive at your destination. So the use cases has to do with having a level of trust for specifically autonomous driving and to ensure that you would actually arrive at your destination safely. There are many movies that depict what can happen when systems are compromised. There are loopholes in every tech system. It just has to come to the point where someone would find that loophole. So that is what the drawbacks tend to highlight. The fact that in case something like this is compromised, where you don't have control. Because, even right now, with vehicles that we drive, we have a certain level of control. If we are to give control, it's going to be like, I would say like 80% we can control the steering and everything. But there are instances where you are unaware, the brake could fail. Your engine oil could run out, or your heating system in the car could get an issue and your car could experience overheating. So there are these ones that are still issues that you can't control. When they crop up, they tend to present issues and present problems. So even with that, rolling it all back and giving total control to a vehicle to move on its own, yeah, it has a problem. And there are also these test case scenarios where the implementation of V2X has shown undesirable flaws, where vehicles just tend to veer off the road on its own. It heightens the anxiety of people as to whether it is going to be ideal to implement or to adopt this kind of technology. Towards the growth of AI, even right now, and even towards humanity implementing and adopting more technology to ease our way of living, there is the idea where we become overly reliant on tech. So when that happens, and with the advancements at which tech is moving, in the case where over-reliance becomes a problem, if the vehicle has to relinquish its hold of the ability to drive, what happens to the driver who, for example, does not have enough knowledge to be able to take back control and ensure that vehicle safety is guaranteed? Because there could be that future ahead. If cars are rolled out to be totally autonomous to the point where you don't even have to go to the driving school again. So if that happens, there could be many problems that could be presented in case the system fails. How do you lean back to an already traditional system? It's how we've seen vehicular communication develop, where initially we had just manual transmissions, right, with vehicles. And then we got the automatic transmissions where you don't have to be changing the gears. And we saw a huge shift in people having complete control of the vehicle, because now there is an ease to changing gears and everything. There was a lot of positives that came with it, but there were also the negatives where people tend to have no idea what to do when the vehicle actually experiences a problem, particularly with its gear shifting. Because it's totally automated, there is that lack of knowledge in that field. So if we are to look at that portion as a very small, steady case, we could project to realize if the entire system is automated and people have totally no reason to have control over the vehicle. I think particularly it would be good to look at it mostly based on the environment it's rolled out in. For places where accidents are very prevalent, I think it is important to observe what is causing the accidents. If it's because of human error, then implementing such a system becomes beneficial, right? So that it eliminates that issue that is being faced within that environment. But in other fields where I think accidents are not as prevalent, implementing that may be a bit of a con in its totality, because it's likely some other environments have drivers who are very trained to ensure that they maintain proper driving ethics. For that environment, it may be more ideal to have it as a mix and not to totally automate. I think to weigh its pros and cons, it's very dependent on the environment where it is implemented. I think in the past, in previous news items that I saw, there was the move towards cellular portion of communication and networking was to be introduced. Now, some countries actually did not totally push for that, whereas other countries embraced it and rolled out quicker. So I know that there are some implementations in its broadest form, particularly for CV2X in China, where they've actually pushed to roll it out in its broad form. In the US, it's controlled in its form. Both countries are controlling it properly, but there is the way they've rolled it out differently. And I know V2X communication is also being rolled out in some other countries such as Sweden, and notwithstanding Korea. So I think there is the prospect for them to share ideas for identifying which communication is ideal. So most countries could liaise and observe when it's very proper to lean towards CV2X, when it's good to still go towards side-link communication. And with that, it will build the community for enhanced transportation safety. Yeah. The transportation industry in itself is quite competitive. So you see a lot of vehicle brands, So most vehicles seek to bring up the newest technology with their brand, So maybe there is the possibility where some car companies and some brands may choose to make sure that these portions of the technology is only patented to them. There are some basic information that can be shared. For example, cell range, the kind of wireless bands that they can use, right? But some of them which are very intricate to them, to these specific brands, may not be shared. And it will be very specific to just them. So there is the prospect for sharing, but then there is also the idea where some information will not be shared at all. For the future, I expect transportation to really experience the highest level of safety, highest level of efficiency, and highest level of effectiveness with its implementation. Because the idea is to ensure that humanity has the best experience and the safest experience with vehicles. With V2X technology, it would totally extend to other modes of transportation. And with that, my hope is to see a very improved transportation system vehicularly and even towards other transportation models. It's got a lot of prospects and it's quite exciting, actually. Yeah.